Hey everyone! Thank you for joining us for the next episode of our Spotlight on GitHub Advanced Security series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speaker for today. Andrew, thank you so much for joining.
Awesome. Thanks for having me, and welcome everyone. I'm here today to talk a little bit about securing the software supply chain in the era of AI development. My name's Andrew McCoy, or as everyone here at GitHub knows me, Moose. So I've been at GitHub now going on, I think, 7 years. Worked in open source security, and once upon a time was a DevOps developer in insurance. Being in the Connecticut area, that's what you usually have to start your career. So had a unique perspective of watching software development change over the years. So how I kind of view this and what we'll walk through today is really what the foundation of this is, how open source has exploded over the years, what we've been doing at GitHub to help with these things, both for open source as well as for how folks can secure your own development pipeline. And then kind of Act 3 there is a look forward at what are some of the newer risks that are coming in? How can you make sure that you're resilient in this ever-changing era now? So let's start at the beginning to understand how and why we're at where we are with supply chain security and how it's changed over the years. At the very beginning, modern software development, 98% of the commercial code bases contain your open source software. The average app has well over 1,000 open source components. The joke used to be when you download Maven downloads half the internet when you begin building your project. And then looking at some of the trends, even from Maven Central through, we're approaching 10 trillion open source downloads last year. This is just a huge explosion. I remember some of these numbers when it first crossed 1 billion about a decade ago. And then so all of the code that you're writing or AI's writing and helping you write these days is comprised of 10 to 20% of that code. You're coming up with an idea, you're ideating. Projects also are bringing in, if you're just building a front-end framework or an MVC project, you're bringing in all those direct and transitive dependencies. And this has been the trend now for 20 plus years. It's been exploded as package managers become a lot easier. Package managers are no longer written in XML, a la Maven, and some of the older ones, they're becoming a lot more modular. And so if we take a look at some of these forced security incidents and how they've changed the thinking over the years. SolarWinds back in 2020 was compromised your build systems, and it made a way for the attackers to gain entry into your internal networks and the code that you're writing. Log4Shell was I always used to joke when I would do demos that what if there's remote code execution in your logging framework? Well, in 2021 there was, and it was one of the most pervasive open source vulnerabilities that happened. Working here at GitHub, we helped a lot of customers in finding impact via using CodeQL queries and being able to run that, but also just being able to know that where you have the usage of the open source dependency in your environment is half that battle as well, which we'll get into. And then you have a couple of the newer ones where they're going to be social engineering campaigns. No longer is it a bad actor is looking to attack a major company or a specific target. They're creating or looking for targets of opportunity. Leaving yourself vulnerable, using old unpatched software. Even with some of the latest news around Project Glasswing and how folks are with AI changing security, it's changing on a weekly basis these days. And then with TJ Actions, again, mimicking the SolarWinds attack, something that was put into your CI infrastructure, not the typical attack vector of coming in through one of your regular applications. And so if we think about this total landscape today, most of the breaches are coming through the supply chain. You're having an exploding number of vulnerabilities in your code bases. There's a lot more malicious packages, whether they're being found from account takeovers, which is some of the recent attacks that have happened, but even looking at the doubling of the supply chain attacks over the last several years means the attackers are getting smarter, and they're recognizing the soft targets and being able to make their way in. And so why does this all matter? Why should you know about this? A lot of it is, we all know you don't write 90% of your code these days, mainly because of open source. You don't go and create your own Legos when you're building a new project. You're using Legos from your friend or other projects of yours, of disassembled ones, to build something new. Same thing with open source. You're not going to go create a new authentication framework. And so even thinking about when, what was it, LeftPad happened, that single package being removed from the internet wasn't even a vulnerability, but that package being delisted broke a lot of environments that didn't have it cached. So a single compromise, a single remove, so one domino in the open source ecosystem can have such a broad and widespread impact across many different companies as well as open source projects. And being able to trust those packages that you're bringing, that's where I'm going to get into what we've done at GitHub to continue to help with some of that trust. And then on the regulatory side, there are ever increasing mandates from different executive orders or the Cyber Resiliency Act, which are putting a little bit more teeth in things on the horizon that we need to adhere to. And so just going to take some time now and walk through how we here at GitHub have kind of been helping contribute. I've worked with customers and open source projects in my time here at GitHub across all these different things. So at its core, the GitHub advisory database, backed by our GitHub security lab team, has been a core piece of making sure that open source advisories or open source vulnerabilities aren't disclosed in an issue or put in a tweet or something along those lines. They're disclosed in a collaborative manner with the maintainers of a project, and then are released in a responsible manner with patch software. So this started rough before I came over, and really over the last 5 to 6 years, 7 years has really heightened. And you can see the total number of advisories that we published, as well as all the ecosystems, and we're continually in the one of the top CVE publishers. And this is really continues to support the maintainers in these ecosystems, giving them a responsible, good pathway to disclosing vulnerabilities, while also collaborating with the security researchers. As AI tools are finding more vulnerabilities, this is creating more interactions and collaboration with the maintainers to make sure things are released properly. We can just see here some of the advisory surge. We just recently released malware advisories. We've been tracking it for a while here. And so if you look at the growth of these over the last several years, it's just a continually growing problem. And these are packages that are being consumed as part of your pipelines, and making sure that you're looking out for them. And so our other aspect of it, we have our advisory creation team. We also have our GitHub security lab team, which is going out and partnering with open source project in finding vulnerabilities and patching them, as well as continuing that responsible disclosure piece. So this team, one of our great partners here that we work with, also helps support our bug bounty program. They have a blog where they talk about the work that they do, as well as publishing the statistics where I talked about with the advisories there. And so how does this all come together for you as an open source user or a GitHub user at the end of the day? That's great, Andrew. Cool information. But how do we actually get some of this information? How do we make sure we're in a good position moving forward? And it all starts at the dependency graph. Dependency graph tells you what is in your application. So parsing your manifest file, the lock files, as well as being able to take a list of your dependencies, the dependency submission API, as well as automating that through some of our configuration utilities that we've rolled out. What this does, it allows you to map your direct and transit dependencies and get a better visibility into your application within your repository. And from there, if there's an advisory within the range of the component, so let's say you're using jQuery and it's got version 1 has an advisory and that's in your dependency graph, we're going to generate a Dependabot alert for you. And if there's a path forward that doesn't have an open advisory, we're going to be able to provide you that security update. And that's where Dependabot has been functioning for years now. 75 plus million PRs generated in 2022 alone, and that's with some older data. One of the other cool pieces we actually just released too is being able to auto assign AI agents to fix your Dependabot alerts. So there's a blog article where we're talking about that you can begin playing with that as well. So really continuing to evolve that ecosystem really helps support those things. But how do you continue to make yourself secure? And this is where it gets a little bit boring going into some of the CI best practices, but really our Artifact Attestations realm is where we've been building this out for about 2 years now. And this allows you to harden your build pipeline to make sure that your builds are immutable, that you have, you're using the centralized actions, things that you know aren't going to be tampered with. And then you can sign your built artifacts as well as verify them as part of your deployment processes. This was one of the core things that I did years ago building out CI/CD and deployment automation was once you build something, you want to make sure you're deploying that same thing to every single environment repeatedly. And by doing that verification piece before you push it into your environment, that's just continuing to make sure nothing was tampered with and you're not subjecting yourself to all those different attack vectors. And really, at the end of the day, you can sign and verify anything, whether it's the different binaries or container images, or we used to package things up into a zip file with some deployment scripts. So you could go ahead and verify that. And we at GitHub, we're managing the root certificate authority for that. So that's available with your GitHub Enterprise Cloud today. Just use it via actions. The GitHub hosted runners will get you some of these things out of the box. So if you look at using GitHub hosted runners with some of the appropriate configuration there of immutable actions, you're going to go ahead and be able to get a build level up to 3 of the SLSA specification, which isn't really mandated for some things yet, but it could be. But also when it comes down to it, it's a best practice to make sure that your build pipelines are immutable, that they're auditable, and that they're secure, so that when something potentially does sour or go wrong with it, you're able to quickly get something into production and patched in a reliable manner. That's really the biggest dividend here is it's the evolution of the DevOps work of making sure your things can go fast. Well, now let's continue to make sure they're going fast and securely, so that as you continue to increase your velocity, you're doing it in a secure manner. All right. And so when you think about where we've been going over the last several years, 2 years or so about this, I've worked with the team when we initially began doing this in a public beta, and I got excited about it then, really because it allowed GitHub to begin giving visibility into your deployments, tying that repository into where it exists in its deployment SDLC lifecycle. And then we've continued to grow that over time. And now we've added the linked artifacts view and code-to-cloud traceability. So you're able to import results from your runtime environments to know if something's deployed in production, is there any runtime risk to it? And I believe we also just added Dynatrace as one of the partners in that as well to get some of that telemetry. So really, this gives you the ability to better filter your alerts on what is in a repository to make sure that you're prioritizing fixing things that are going to have the biggest impact for yourself. And so when you think about how GitHub supply chain in this era helps you, is that defense in depth I mentioned before. So we have the ability, we have our advisory database, we have our security lab, so producing those signals that make sure the alerts are surfaced in a timely manner. In the latest couple of supply chain incidents, we had our alerts published in a matter of hours of things, and we were working directly with the maintainers on them. So really on that front line, the tip of the spear, working to make sure that the information is available to you, and then alerting you to it via the in-product tools via Dependency Graph and Dependabot alerts. And now being able to automate that fix via assigning it to a Copilot agent, and then going ahead and improving it. So as you build your new pipelines, or improving your current pipelines, making sure that you're assigning and verifying your artifacts as they're going through them to give you that auditability and traceability, and then verify that as well, as I mentioned. And then so this is great. So, and then what's going to change as we begin to look forward here? And so really some of these stats I pulled together this week. 84% of the developers are now using some of the AI coding tools. We have 45% of the AI generated code now contains security flaws. These are things which are always going to be debatable. At the end of the day, we know when we go faster, we need to have security baked into that. And that's one of the things we've been working with at GitHub with our CCA is security has been embedded into that review cycle. So whether you're using our security products in that repository, we're still applying security rigor to that code as it's being written, because the last thing we want to do is really continue to produce insecure things. But one of the new threat vectors that I've been reading up on recently is really about Slopsquatting. So we've heard typo squatting, name squatting, and all the different variations about it. And this one's actually been pretty interesting, is because the threat actors are looking at what the hallucinations are and misspellings for packages, or packages that maybe were there once upon a time or in a different ecosystem. And then they're going ahead and trying to sit on top of that and catch that. So that's really one of the newest attack vectors, which, there's got to think of new ways to really think about how you are protecting this. And one way I would probably think about this is just making sure you're doing some local checking of your internal registry. Do these packages exist? Are they new? And doing some vetting, proxy checks, and being able to have a trusted software platform is going to be one of those key components of this, making sure that any new components coming into your environment go through some sort of vetting process before they're made available to your automation systems. And then so thinking about how you're going to be able to have some best practices that make yourselves a lot more resilient moving forward is making sure you're not using mutable tags in your actions. So making sure those are pinned to releases of the commit SHAs, treating your AI code as untrusted. So the OpenSSF fund or group says, you are the developer, A as your assistant. There are some things I've been reading recently around even code review changing, around asking coworkers that grew up in an AI coding era, like, well, why was that decision made? And because AI did it. And so things are going to get advance a lot more, especially as the AI swarm continues to grow here. And so automated detection, so making sure that you're enabling Dependabot and the auto triage as best practices, your things that are going into production. So every application that you build, there's that maintenance cycle to it. There's security hardening, security review, making sure you're not opening, pathways into the corporate network. Those are real review processes that need to continue to happen, as well as making sure that you're using the appropriate best practices of pipelines in artifact attestations there. Another, continuing to visit, your scope of tokens. making sure you're not accessing, giving too broad of access. And then still continuing to have human review at a certain point, even if that human review is pushing a button at the end of the day. That could be just that gate that prevents that rogue deployment from going out. And so currently, what works is doing the basic things right, revisiting what your pipelines are, where are your gates, where is everything automated, where can you insert some of those human choices? Is automating everything going to be the right choice? Yes, usually, but at the end of the day, you don't want to automate it too much where bad things can go out on you at the end of the day. Let's see. And then so SLSA level 3, I know I mentioned that briefly. That's really that standard out there for making sure that you have your hardened builds again, making sure that you're mapping to a standard, those best practices, and a really great website that documents how you can begin getting started with that. We make it easy by doing it with GitHub and GitHub Actions. And so just as we're wrapping up here, some of the key takeaways is you're responsible for the code you didn't write. So I remember when I was in the military, like if someone in my platoon or my squad messed up, we were all responsible for it. So really being able to say, well, AI wrote it really just isn't it, but also, well, it's in the open source code. You're responsible for that book of work. The threat is continuing to accelerate. Your supply chain attacks are doubling. Looking at the statistics, you need to make sure that you're resilient and you're having the appropriate safeguards up. You're using the right tools that are in place. You're implementing the right processes with the right people in your organizations. Remembering that AI agents are going to amplify opportunity at risk. If you're okay with the risk, great. But think about ways that you can continue to insert the right amount of reviews for yourselves is always going to be key there. And then provenance is actually more important than ever across your SDLC. Being able to answer the question, where did that image come from? Where was this thing built? Doing the built signing and verification is going to be key, especially if you're dealing with an after action incident or doing investigations into what went wrong. Being able to know, that was always the first step for me when we would be diagnosing a broken system is, well, what changed? And being able to know that nothing could have possibly changed in the environment by a human going in and touching anything is such a relief at the end of the day. And so here's some of the resources of some of the things I talked about. And I got through things pretty quick, so I don't know if there's anything in the chat as questions. I don't think I can see it. All right. We give folks a minute or two, and then got through it kind of quick today, but that's quite all right. Hopefully folks got some benefit out of this. We can end early if not. All right, everyone. Thanks for tuning in. Have a great day.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.